Assalamu alaikum. Welcome to lecture number 14 of Software Design and Architecture. I am your course instructor Fahad Anwar. So, students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So, students, if you remember what we discussed in our last lecture, we see how quality attributes are actually being involved in software architecture, and we see three different levels of attributes which are actually being involved in the software architecture, where we see the implementation attributes which are not non-observable at runtime, and then we see the runtime attributes which we call observable at runtime, and third one is the business attributes, and the last topic of our previous lecture was the trade-off pair between different quality attributes. So students, it's about our last lecture discussion. Now let's start our today's lecture discussion. So here is brief objective of our today's lecture discussion. We will see how architecture actually addresses the non functional requirements, and then we see the static and dynamic quality attributes which are actually resembles with the implementation attributes which we see in the previous lecture, and we call them a non observable attributes, and the runtime attributes which are actually correspond towards the dynamic quality attributes and which we call the observable at runtime. And then we see the new topic quality scenarios, and the last we also see common quality attributes, where we see further classifications of quality attributes. So students, let's start our today's lecture discussion. So students, the first one is software architecture design actually non-functional requirements. So students, what are the functional requirements and the non-functional requirements? So students, all of you already studied the software engineering subjects, and you are well aware about these two terms, functional requirement and non-functional requirement. I will not go into more deeper details about the functional requirement and the non-functional requirement because you are already studied these two terms. I will only give you a brief or abstract overview between these two kind of requirements. Students, functional requirements are actually those requirements which actually provide services to the system, or what the system should do, or what the system shall do, what kind of functionalities will be provided by the system. It all comes under the umbrella of functional requirement, and functional requirement actually comes directly from the customer, and there are different methodologies available to represent the functional requirements. Mostly we utilizes a use case model diagram to represent the functional requirement, or you can say that the use case model gives the functional perspective of the system. And what is a use case model? We briefly and very comprehensively discuss this use case model in our unified modeling language topic as well. So you are already aware about the use case model, where we have a boundary in where we have a different processes and the primary actor and the secondary actor, and in this use case model we see how primary and secondary actor actually being interacting with the system, and what kind of functionalities is actually provided by the system. So functional requirement is actually all about what kind of services the system shall provide, and these functional requirements actually directly comes from the customer. And now the second is non-functional requirement. So students, basically non-functional requirements are those requirements which are actually concerned with the characteristics of the system. Non-functional requirements are hard to measure and hard to achieve. Quality non-functional requirements are actually our quality requirements. And what are the quality requirements? Are the quality attributes which actually refers to any measurable characteristics of any system, like reliability, portability, availability. All of these kind of quality requirements are actually correspond to non-functional requirements. These quality attributes we are discussing from our last 2 3 lectures. So till here I am assuming that you are now well aware about these quality attributes which are actually being addressed in the non-functional requirements. So we can say that these non-functional requirements are not related to a particular use case, because these non-functional requirements are actually depicts the overall system attributes like reliability, availability, performance, etc. And uh, in the non-functional requirement, we also see in previous lecture there are different trade-off pair between different quality requirements, like we see how scalability and performance trade-off pair. So there are different trade-off pair between different quality requirements. We can't achieve all kind of quality or characteristics of any system in a single architecture. So that's why there exists some trade-off between different quality pair, etc. And now more architecture dependent on these non-functional requirements rather than the functional requirements, because non-functional requirements are more important for the user or the customer, and these non-functional requirements are hard to measure and hard to achieve. So these non-functional requirements are actually determined by the architecture and the stakeholder of the system within the organization. So stakeholders, you are already well aware about the stakeholders are the anybody who is directly or indirectly interested in the system are our stakeholders. Stakeholder can be internally or can be externally. So there are different kinds of stakeholders. I am not going to more deeper details about stakeholders. You are already studied these terms in software engineering as well. So we can conclude our non-functional requirement is that these non-functional requirements can be described in terms of quality attributes, and these quality attributes are addressed in the architectural design. Students, if you remember in our previous lecture, I tell you again and again, actually software architecture is actually concerned about the quality attributes of any system, while the detailed design is actually concerned about the functional requirement. So we can conclude that architecture comes before the detailed design, and architectural design is concerned or responsible for the non-functional requirements, and the detailed design is comes after the architectural design, and the detailed design is concerned or responsible for the functional requirement. So it's all about the how software architecture help us in the non-functional requirement with respect to quality attributes, which are we are going to discussing in previous lecture and in this lecture as well. And now what are the quality attributes? So students, still here we see different types of quality attributes. So basically quality attributes is a measure of excellence or the state of being free from the decision of defects. Quality is any measurable characteristics which tells us about the how much system is actually meets the needs or the characteristics which is demanding by the our user as well. So implementing quality attributes make is it easier to differentiate a good system and a bad one. So attributes are overall factors that affect runtime behavior and system design and user experience as well. And now these quality attributes are further seen into two different perspectives: static quality attributes and dynamic quality attributes as well. These static quality attributes are basically the implementation attributes, which we also called non-observable at runtime, and we also see these static quality attributes in our previous lecture as well with the name of implementation attribute. And the second one is dynamic quality attributes. It's actually about the runtime attribute, or we also call them observable at runtime. We also see this dynamic quality attribute in our previous lecture as well. So here static quality attribute and dynamic quality attributes are already discussed. I will give you a little bit about these two terms in a nutshell. So static quality attributes actually reflect the structure of a system and organization directly related to architecture, design and source code. So we can say that they are invisible, these static quality attributes are invisible to end user but affect the development and maintenance codes for like modularity, testability, maintainability. All of these are static quality attributes. And in the dynamic attributes, it actually reflects the behavior during the runtime, because dynamic quality attributes are observable at runtime. So they are directly related to system architecture, design, source code configuration, deployment parameters, environment and platform itself as well. And they are visible to end user that exist at runtime, for example throughput, robustness, scalability, etc. So there are basically major difference between static quality attribute and dynamic quality attribute is static at quality attributes are invisible to end user, while dynamic quality attributes are visible to end user because it actually exists at runtime or observable at runtime. So the next one is quality scenarios. Now students, what are the quality scenarios? It's a niche topic. We will discuss this topic in very detail in this lecture and in the coming lecture as well, with the help of some real world quality attribute scenario practices. So basically quality scenarios specify how to prevent a fault from becoming a failure. So to overcome this, they further divided into six parts based on their attribute specifications. So these are the six elements of this quality scenario: source, stimulus, environment, artifact, response, and response measure. So what is source? Source can be internal or external entity like people, hardware, software. These are comes under the source. And stimulus is what you can say. Stimulus is an event. So like stimulus is an event or a condition that needs to be considered when it arrives on a system as well. And the environment, as the name described, environment is about uh, the event or stimulus occurs within certain conditions, and the artifact is about a whole system or some part of its, such as processors, communications channels. It are all about the artifact. And the next one is response. Like response is about an activity undertaken after the arrival of stimulus or event, like such as detect faults, recover from fault, like disable event sources, etc. And the last one is response measure. Actually this response measure should measure the occurred responses so that the requirements can be tested. So these are basically these six elements of quality scenarios. These are also explained in this slide as well. You don't need to remember these quality scenarios. Students, we will discuss these quality attribute scenarios in practice in our coming lecture. We always see how different quality attributes can be utilized as quality scenarios with the help of some real world quality attribute scenarios in terms of practical practices as well, will be covered in our next lecture. In this lecture you will only need to generally understand the quality scenario terms. So here we discuss the six basic terms of quality scenarios. First one is source of stimulus. Source, which we call the entity gathering a stimulus, like it can be an actor, sensor, actuator, it can be internal or external, etc. And then we see the stimulus, which we call a condition or an event arriving at a system, including faults, stated intentions by actors, etc. And then we see the environment. Environment is actually about the conditions surrounding by the stimulus or environment. So environment can be normal operation, like degraded operation, like overload. These are different kind of operations. And then next one is the artifact. Artifact is actually about the part or some parts of the system stimulated. And the next one is response. The response is about the response the system takes to the stimulus or the event. And the last one is measurement of the response, like how the response can be measured and tested. So these are the six quality scenarios. So here is the graphic pictorial representation of quality scenarios. Like you can see that about this quality scenarios as showing in the diagram. So first of all, source of stimulus is comes where the entity gathering the stimulus, which could be an actor, actuator, or sensor, and so on. So and then based on this stimulus, so stimulus is a condition arriving at a system, which can be a fault, stated intentions by actors. And after getting the stimulated events from it goes to the environment. And environment is actually about the condition which actually surround the stimulus. And environment might be normal operation, degraded operation, overloaded operation. These are different kind of environments. There are three kinds of environments: normal operation, degraded operation, and last third one is the overloaded operations. And the artifact is actually about the part or some parts of the system being stimulated. And now the next one is about response. Response is an activity undertaken after the arrival of stimulus, such as detect faults, recover from fault, etc. And at the end, we actually measure the response of measure. about should measure the occurred responses so that requirements can be tested. So in this last measure of response, you can say that how the response can be measured. So students, it's about the it's in this diagram we see the quality scenarios, how these elements is actually moving from source of stimulus to response of measure. सो स्टूडेंट्स, हमने देखा कि क्वालिटी सिनारियोज क्या हैं, इसके 6 एलिमेंट्स क्या हैं, और हर एलिमेंट के अंडर हमने देखा हर एलिमेंट का टास्क क्या है. सो अब हम इस क्वालिटी सिनारियोज की डिफरेंट क्वालिटी एट्रीब्यूट्स की विद रिस्पेक्ट टू डिफरेंट क्वालिटी एट्रीब्यूट्स, इन क्वालिटी सिनारियोज की डिफरेंट प्रैक्टिसेस को हम अपने नेक्स्ट लेक्चर में विद द हेल्प ऑफ एग्जांपल्स देखेंगे कि अबाउट दिस क्वालिटी सिनारियोज जो हैं प्रैक्टिसेस में हमारे पास कैसे वर्क करते हैं, so that you can get better idea about the quality scenario. Till here in this lecture you only need to clarify your concept about these 6 elements of quality scenario. So in this lecture you only need to cover about what is source of stimulus, what is environment, and what is artifact, response, and last one what is the measure of response. So basically these are the 6 elements of this quality scenario. You only need to understand these 6 elements of quality scenario. In the coming lecture I will briefly give you different examples, or I will provide you different quality attribute scenarios in practice as well, so that you can get better idea about the quality scenarios. So the next one is common quality attributes. There are different three different kinds of quality attributes: system quality attributes, business quality attributes, and architectural quality attributes. The first one is system quality attributes. So students, these are the system quality attributes we are discussing already. These system quality attributes like availability, modifiability, performance, security, testability, and usability. As the name suggests, availability is concerned with the about the system failures, like how much time the system will be available, like it will be available to the user for 24 by 7. Like there are different matrices are available to measure the availability. So these are already discussed, so I am not telling you in more detail. So next one, the modifiability is actually concerned with what we can change, what when our changes can be made, and who makes the changes. So modifiability is all about the changing, which we also call the maintainability. So the next one is performance is quality is concerned with the response time, and similar measures for various events is discussed in this performance quality attribute. And the next one is security. All of you are well aware about this. Security is actually concerned about the confidentiality, integrity, or authenticity, etc. And testability and usability are also discussed in our previous lecture as well. So students, these are the 6 quality at system quality attributes which are covered in at the system level. So these 6 quality attributes are covered at the system level. And now the next level is business quality attributes. So what are the business quality attributes? In our last lecture we also see some 1 to 3 perspectives of business attributes. Let's discuss these business quality attributes in more detail. The first one is time to market, means architectural reuse affect the development time. And the next one is cost and benefit, as the name suggests, like in-house architectural expertise in cheaper than the outside expertise. And next one is the projected lifetime of the system, like long life system requires architecture that are modifiable and scalable. And the next one is targeted to market, which actually in which we say architecture affects what platforms will be compatible and incompatible with the system is discussed in targeted to market. And the next one is rollout schedule. In rollout schedule we see if functionality is planned to increase over time, the architecture need to be customizable and flexible, etc. And the last one is integration with legacy system. What are the legacy system? Basically legacy systems are our traditional system which are already running in the environment. We call these kind of systems legacy system. So the last business quality attribute is integration with legacy system, like the architecture of the legacy system being integrated will influence the overall system's architecture. So all of these 6 are business quality attributes. So the last one is architectural quality attributes though. So in this third level of common quality attributes we are more interested towards the architectural quality attributes. So first one is conceptual integrity. So students, what is conceptual integrity? Basically Conceptual integrity is the underlying theme or vision that unifies that design of the system at all levels. Like we can say that the architecture should do similar things in similar ways. Conceptual integrity is the most important consideration in the system design. Or conceptual integrity, we can also say that the architecture should do similar things in similar ways is about the conceptual integrity. And the next one, quality attribute at architectural level, is correctness and completeness. So this is well explained, as its name suggests, correctness and completeness for the architecture to allow for all the system requirements and runtime resources constraints to be met. A formal evaluation is the architecture best hope for a correct and complete architecture. सो करेक्ट एंड कंप्लीट आर्किटेक्चर के अंदर हमारे पास ये एसेंशियली हमारी ज़रूरत क्या है कि जो आर्किटेक्चर है हम अलाउ करें कि वो सिस्टम की जो तमाम रिक्वायरमेंट्स हैं, जो रन टाइम के रिसोर्सेज हैं, जो भी कंस्ट्रेंट्स हैं, हमारा आर्किटेक्चर करेक्टली और कम्प्लीटली वे में उसको मीट कर रहा हो. So all of these kind of things are actually discussed in the correct and completeness. And the last one is buildability. Buildability is actually about allows the system to be completed by the available team in a timely manner and to be open to certainly changes as development progress. So जो बिलेबिलिटी है ये अलाउ करता है सिस्टम को कि वो उसको हम कंप्लीट कर सकें अपनी अवेलेबल जो हमारे पास अवेलेबल टीम है उसके साथ एक स्पेसिफिक टाइम के अंदर, जिसके अंदर हम अपने डिफरेंट ओपन सर्टेन जो हमारे पास चेंजेस हैं डेवलपमेंट प्रोसेस में उसको कैटर ऑफ कर सकें. सो वी कैन से दैट बिल्डेबिलिटी अलाउज द सिस्टम टू बी completed by the available team in a timely manner and to be open to certain changes as development progress. So students, these are three different architectural quality attributes: conceptual integrity, correctness and completeness, and the last one is buildability. So these three quality attributes are more prone towards the architectural quality attributes. So students, till here our lecture number 14 is ended.